Okay, so today we'll be doing rationalizing denominators. Now, we're actually going to do this for both radicals and imaginary numbers or complex numbers because really the same things come up. So, why do we have to do this? Well, this sort of thing will come up a lot when you're working with formulas and stuff in geometry and in algebra 2, where you've got fractions, and with your fraction, you end up with a radical in the denominator. Now, you're not allowed to leave your answer with a radical in the denominator, and kids have asked me why, and I've often made up lies that sound good because the truth is I don't really know. I actually looked it up on Google and tried to find out, why do we have to do this? And the only answer I found, which is kind of funny, was it said it helped us understand the value of the number better. But I think when I'm done doing this, you'll realize I don't know, it doesn't really do that. So the only reason I can give you for why you have to do this is that is just sort of how the world works, and that's how all the answers are given in math books and stuff. So it's actually pretty easy to do. What this means is if we can't have a radical in the denominator, we have to have sort of an integer down there. And the easiest, fastest way to do this is we're going to multiply this by radical 3 over radical 3. Okay? And the reason we're going to do that is quite simply, if you square a radical, which is really what I'm doing here, this is like, squaring radical 3 by multiplying it by itself, what we get is just what is on the inside of the radical. So in this particular case, it would cancel out the radical symbol and we would just have a 3. Up here on the top, we get 6 radical 3, and this is sort of like what I was talking about. For some reason, the powers that be have decided that this is okay and this isn't. So you can have one on the top and not on the bottom. This is the same number with a rationalized denominator. Okay, so that's pretty much what we're doing here. So then we're going to go to example B here. Same thing. I kept the radical the same, but this time I put the 6 inside of the radical. So what effect does that have? So I'm going to use the identity property. Even though you learned that in 7th grade, this is 1. Whenever you multiply a fraction by 1, it keeps its value. So whatever you multiply the bottom by, you got to multiply the top by. So the same is true here when we're rationalizing denominators. So we have down here a 3. And then up here, what we have is we have the 6 and the 3 now are inside the radical, which means that is radical 18 over 3. Okay? But we're not done because now we have a radical that can actually be simplified. 9 is a perfect square, so 9 times 2 is equal to 18. So this can be changed to 9 times 2 over 3. And then that is equal to 3 radical 2 over 3. But we're still not done because if you look, we actually have the coefficient of this radical 2 and the 3, they can cancel out. So I can divide both of these by 3. So this one would actually be radical 2. Okay? Now we get to C, which is going to look probably more or less like what we did with B. It just has the added fun that there is a 10 on the outside here. So I'm going to go ahead and start by multiplying this by radical 7. And that's going to give us a 7 down here. And then up here, I've got a 10 root 5 times 7, because they're both inside the radicals. So that's 10 root 35. So that one actually was probably easier than B. Really quick, I just thought of another example. What would you do if this was a 2 down here? How would this whole sort of thing change? The way it would change is, remember, if you do radical 7 times radical 7, you get 7, but see that 2 is still there? So you would multiply the 2 times 7 to get a 14. So I just thought of that. I could see that being a question that you'd run into, so that's what you would do if that were to happen. So now I'm done with rationalizing denominators. we're going to look at rationalizing denominators with complex numbers, and the same holds true. We can't have any complex numbers in the denominator. I didn't specifically look that up on Google. I was only looking at the rational numbers, but I imagine the answer is much the same in terms of like why we have to do this. So what I'm going to do is pretty much on all of these, you're going to do the same thing, which is you're going to multiply it by I. Okay. If you didn't get a chance to watch the last video on calculating with complex numbers, you're going to need to look at that, because this is what I was talking about, where the I squared comes up a lot. This is one particular case. Remember, I is equal to the square root of -1. So I squared is equal to I, which we said was -1, squared. So that cancels the root out. So we know that that's equal to -1. So remember that I squared is equal to -1. So this is going to be a 2 times I squared with a 6i on the top, and then we have 6i on the top, and then that is 2 times -1. So that's -2. So now, just like we would if we were working with variables, you have a 6 and a 2. This actually goes into that. So that would be -3i. Okay? B down here. So what's going to happen on this one is we're going to do the same thing. We're going to use I, and that's pretty much the standard move on all of this stuff. Except on the top, in the numerator, we're going to end up doing like distributive property. So, because there's sort of two terms up here in this binomial sort of complex number on the top. So that means I have a 2i squared on the bottom, and then on the top I have 8 times I, and then I have -9i squared. Okay? So that means I have an 8i. This is -9 times, remember, I squared is -1. And then down here, I have 2 times -1. And so I get 8i plus 9 over -2. Now that's the answer, but one thing I sort of noticed in math books and worksheets and stuff is they don't like to have the negative down here. I don't really know why. So a lot of times what I'll notice is that someone went and took this fraction and sort of multiplied it by -1 over -1. So even though like I'm totally fine with this right here, if I don't want a -2 down here, this is what I'm going to have to do. I'm going to have to multiply it by -1 over -1, which what effect will that have? Well, I'll have a -8i minus 9 over 2. And so the reason I bring that up is a lot of times you'll do what I just said to do, and then you'll get this, and then you'll look at the answer in the back of the textbook or on the worksheet, and it'll have this. You'll be like, what did I do wrong? Well, that's really sort of what happened, is that a lot of times they just wanted it a certain way. I don't know if it was the algorithm of the worksheet or what. But before I finish, I just wanted to mention this rationalizing denominators. This is also known as dividing complex numbers. So we did calculate with complex numbers, but that was addition, subtraction, and multiplication. This is how you would divide it. But dividing and simplifying are really the same thing. And so that concludes the lesson on rationalizing denominators.